Now we'll see the function for inserting a node before a given node. Already we have seen this creating the new node. We are creating the new node here by using the getNode function. Then the pointer is starting at the start, and while the pointer of the data is not equivalent to value, the pre-pointer equal to pointer and pointer equal to pointer of next. These things, if you see in the example, we are starting the pre-pointer and pointer here. 10 is not equivalent to 30, so this will become the pre-pointer and this will become the pointer. So 20 is not equivalent to 30, this will become as a pre-pointer and this will become as a PTR. That means always pre-PTR equal to PTR, PTR equal to PTR of next that we are doing. These two steps we are doing until whatever the data that is required. In our example it is 30, because 10 is not equivalent to 30, PTR equal to PTR of next. The previous node will become as a pre-PTR. Like that we are finding out up to this one. Suppose consider that someone has asked me to insert before 70. 70 is not present. That means I will check 30, we will check 40, and once again we will come here. That means once we have traversed the complete list, that means the element is not present, we are displaying. That we are showing here. See here, if the PTR of data is not equivalent to value, pre-PTR equal to PTR, PTR equal to PTR of next. In the meantime, whenever the PTR is becoming as a start, that means we have completely traversed the list, the element is not found. Otherwise, what we are doing, the two steps that we are doing are new node of next equal to PTR and pre-PTR of next equal to new node. The two steps that we are doing here. Pre-PTR of next equal to new node and new node of next equal to PTR. Now we will see inserting a node after the given node of the circular linked list. Suppose consider that I want to insert 50 after the 20. So as usual I am starting the pointer at the start. 10 is not equivalent to 20. So PTR is equivalent to PTR of next. I am coming here. So 20 is equivalent to 20. That is whatever the node that is required. I have found out that one. If this is the PTR, this will become as a PTR of next. Now I want to cut this particular link and I want to establish these two links. Always we will be doing the right hand side first. That's why new node of next equal to PTR of next, PTR of next equal to new node. These are the two steps that I am doing for inserting a node into the circular linked list after a given node. See, algorithm that we are writing, I am reading the value, what value that I want to do for this one, and I am starting the PTR equal to start. While PTR of data is not equivalent to the value, I am going PTR equal to PTR of next. That I am writing in the algorithm here. We are creating the new node, we are reading the value, we are starting the pointer at start, and I am repeating these steps while PTR of data is not equivalent to value. Whenever it is not equivalent to value, PTR equal to PTR of next. In the middle, if the complete traversal of the list is over, that means the element is not found. So I am displaying element is not found and I am going to the stop. That is I am coming out. Once the element is found, what are the two steps that we are doing? New node of next equal to pointer of next equal to new node. So new node of next equal to pointer of next equal to new node. That we are writing in the form of function. We are creating the new node here and we are finding out what is the value after which the data to be inserted. We are taking the value. I am starting the pointer at start. While PTR of data is not equivalent to value, always I am going to the next pointer, and in the meantime if the PTR is start, that is element is not found. So if the element is found, the new node of next is pointing to the pointer of next and pointer of next is pointing to the new node. What we have seen in the diagram. New node of next equal to pointer of next and pointer of next equal to new node. That is the activity that we are doing. Now these are the 4 insertion operations that we are having, and the next we will see the deletion of the nodes. There are 3 types of deletions that we are seeing. Deleting a node at the starting of the linked list, that is circular linked list, and deleting at the end of the circular linked list, and deleting in the middle any node. So at first I will see the deleting a node at the starting of the linked list. Suppose this is the starting of the thing that we want to delete. So start will always be pointing to the starting. If this is the start, This is the start of the next. That means I want to remove this particular thing. That means I don't want this node to be a start. I want this node to be start. That is, start should always be pointing to the starting of the next. That I am doing here. Start equal to starting of the next. Previously, the last node used to point to the 10. Now it has to point to the 20. That is, pointer of next is pointing to the start, because already start has been gone to the start of the next. Then whatever that particular temporary node is there, that I am removing. What are the 3 steps that I am doing? Start is going to the starting of the next. That is, the new start is now 20. Now the pointer of next previously used to point to the 10. Now it points to the 20. That is, pointer of next equal to start, and whatever the node I want to delete, I will remove this particular thing. So as algorithm I am writing here, temp equal to pointer equal to start, and I am repeating this step while the pointer of next is not equivalent to start. That means I am taking the pointer from here to the here. So that I am doing by using these 2 steps. So what are the things that we are doing? Start equal to start of the next. Pointer of next will be pointing to the new start, and I am removing that temporary node that we are having. That we are writing in the form of the function. See here, I am taking pointer equal to temp equal to start. Instead of pointer 1, I have taken temp. So while pointer of next not equivalent to start, pointer equal to pointer of next. Start, that is the new start is old start of the next, that is start equal to start of the next. And the last node next is pointing to the new start, and I am removing this temporary node that we are having at the starting of the list. And the next function that we are having is deleting a node at the end of the list. So at the end of the list, suppose consider that this was the linked list that we are having. That means 40 used to point to the 10. Now I want to remove the 40, and the 30 has to point to this particular 10. For that particular purpose, I am starting the pointer at the start, and I am taking the pointer up to the end. Up to the end means pointer equal to start, while pointer of next is not equivalent to start, pointer equal to pointer of next. See here, 10 is not the last one, so pointer equal to pointer of next. 20 is not equivalent to the last one, so pointer equal to pointer of next. 30 is not equivalent to the last one, so that means pointer equal to pointer of next. 40 is equivalent to the last one because 40 will be pointing to the 10. So this will become the pointer, and every time, because I want the previous pointer, I am taking the pre-pointer. So what the link that we want to remove? The pre-pointer of the next link that we want to remove. The pre-pointer of the next, previously it used to point 40, now it has to point to the 10. That's why pre-pointer of the next will always be pointing now to the start. This link has been cut. Now I am freeing this particular PTR. Now the algorithm what we are writing? So PTR is starting at start, while PTR of next not equivalent to the start, PTR equal to PTR of next. Now PTR will be pointing to the last one, pre-PTR of next equal to start. See, this is the thing that we are writing. PTR equal to start, and I am repeating the step 3 while the PTR of next not equivalent to start. What is the step that we are doing? Pre-PTR equal to PTR, PTR equal to PTR of next. And at the end, pre-PTR of next, previously it used to point to the last one, now it will be pointing to the starting. At the end, I will be removing that particular PTR. That we are writing in the form of function. So see here, the pre-PTR and the PTR both will be pointing to the start only, while PTR of next not equivalent to the start, pre-PTR equal to PTR, PTR equal to PTR of next. Once we have gone to the last one, pre-PTR of next will be pointing to the start, and we are removing this particular last node. And if we want to delete a particular node in the list, as an example, suppose consider that I want to remove the 30. So whenever I want to remove the 30 here, what I have to do? I have to search for the 30 where the 30 is present. So I'll start at the starting, PTR equal to start. Is the 10 is equivalent to 30? No, 10 is not equivalent to 30. Now PTR will become 20 and pre-PTR will become 10. Now I'm present with the 20. Is 20 is equivalent to 30? No. So PTR will be 30 and pre-PTR will be 20. Now is the 30 is equivalent to 30? Yes, 30 is equivalent to 30. That means I am searching for 30 from the starting of the list until the ending of the list. So I'll be finding out what is the PTR. Now the previous node is pre-PTR and the next node is PTR of next. What is the thing that we have to do? I want to remove these two links. So now what I am doing, pre-PTR of next, previously it used to point to the pointer. Now what I am doing, pre-PTR of next now will be pointing to the PTR of next, and I will be removing this particular PTR. So see the algorithm for this one. So I am reading the value which I want to delete. So I am starting the PTR at start and I am repeating the step until the PTR of data is not equivalent to value. What are the steps that I am doing? So 10 is not equivalent to 30, 20 is not equivalent to 30. At that particular step, what we are doing? Pre-PTR equal to PTR, PTR equal to PTR of next. In the middle, whenever the PTR is equivalent to the start, that means I have completely traversed the list. The element is not found in this particular list, I will be displaying. So whenever the element is found, what are the activities that we are doing? Pre-PTR of next is pointing to the PTR of next. That I am doing here. Pre-PTR of next is equivalent to the PTR of next. And I am freeing this particular PTR. So that we are showing as a function here. So pre-PTR, PTR is pointing to the start. And I am reading what the value that I want to delete. And while the PTR of data is not equivalent to the value, pre-PTR equal to PTR and PTR equal to PTR of next. And whenever the PTR is becoming as a start, I am displaying that element is not found. Whenever the element is found, what are the activities that I am doing? Pre-PTR of next equal to PTR of next. See here, pre-PTR of next equal to PTR of next. That particular activity that we are doing. So these are the deletion operations that we are performing on this particular circular linked list. Thank you.